Okay, so we're going to go ahead and plug in something close to 0. That's going to give me tangent of close to 0, which is about 0, and raised to the power 0. So this ends up being a type 3 L'Hopital problem. So we're going to introduce logarithms. We're going to take ln of both sides, and that's going to give us access to this exponent that's going to plop down. So x ln of tangent 4x is what we're basically going to focus on in taking the limit as we go to 0 from the right. So that's going to give us limit as x approaches 0 from the right of x times ln of tangent of 4x. So again, we're going to try to plug in and see what happens now. So we have 0, something close to 0, times, we're looking at ln of tangent of 4x. So if you put in something close to 0 for x, that's going to be tangent of almost 0, and tangent of almost 0 is almost 0 in itself, so you're essentially looking at ln of something approaching 0. And remember, the ln graph looks something like this, so if you're going towards 0, this is going to shoot down and go to negative infinity. So the second piece, the first piece 0, the second piece goes to negative infinity, and therefore now we're no longer looking at a type 2, but at a type 3, but a type 2 L'Hopital problem. So now my goal is to change this guy, what I have here, into a type 1 problem. So I'm going to choose to move one of them downstairs. I'll leave the ln upstairs, and I will leave take the x downstairs, making a reciprocal 1 over x. When I do that and check things out now, I have ln of something close to 0, so that gives me, as we saw here, negative infinity. And downstairs I have 1 over something approaching 0, so it's 1 over tiny, 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 which becomes big. So I have a negative infinity over infinity, which now is a type 1 problem, and I can go and apply L'Hopital. So I'm looking at limit as x goes to 0 from the right, and I have to differentiate the top and the bottom. So for the numerator, ln of something is 1 over something. That means 1 over that something, times the derivative of whatever that something is. So derivative of tangent is secant squared. That's going to be secant squared of whatever that thing is. And since that thing, the argument of tangent is not just an x but a 4x, I have to pop out another chain rule, which is the derivative of 4x, which is just 4. So 1 over box times the derivative of box, and that in itself has a box of its own, which pops out another 4. All over the derivative of the bottom is 1 over negative 1 over x squared. Now I have to do some algebra to change this complex fraction into something that's a little bit more manageable. So in the numerator, I have 4, secant square 4x upstairs, and downstairs I have tangent 4x, and in the denominator I have negative 1 over x squared, and I'm dividing these two because that's what that bar says. So I have 4 secant squared 4x over tangent 4x times the reciprocal of the denominator, which gives me, I end up with 4x squared on the outside, secant squared 4x upstairs, and downstairs tangent 4x. So at this point, I am now looking at the limit as x approaches 0 from the right of this business over tan 4x, and I think I have forgotten a negative. So this is a negative and this is a negative. Now when I try to plug things in again, let's see if I get lucky and I get to something that we can evaluate. Plugging in 0, something close to 0, I get 0 for the 4x squared part. Secant squared of 4x, or secant squared of 0, is really just 1 over cosine squared of 0, and cosine squared of 0 is 1, so that gives me a 1. Over tangent of 0, getting close to 0 is 0. So this wasn't all that great because it still gives me 0 over 0, which means I need to apply L'Hopital again. So we're going to have to do a little bit more differentiation. And so I have, notice, a product in the numerator, so I'm going to have to apply the product rule to this. So I'll leave the negative outside and I'll deal with it later. Derivative of the first 8x times the second plus the 4x squared times the derivative of this guy, which is really secant 4x, the whole quantity squared is basically what we're looking at. So when I differentiate that, I bring down the 2, secant 4x, knock that down to 1, chain rule, do the derivative of the inside. Derivative of the inside is secant 4x, tangent 4x, and again, chain rule, that pops out another 4 as well. That all over the derivative of the bottom, which is secant squared of 4x times the derivative of the inside, which is 4. So this looks pretty ugly. Instead of simplifying it, I think I'm just going to go ahead and hope for the best and plug in 0 and see what I get when I plug in 0. So when I put 0 here, this becomes a 1 for secant squared, but the first piece completely becomes 0. Plus, if I put a 0 in this term, 0 in this second one makes it a 1, here makes it a 1, that makes it a 0, and that product 4x squared makes it a 0. So upstairs I basically have 0 when I plug in 0 from the right. Downstairs I have secant squared of 0, which is really 1 over cosine squared of 0, which is 1. So downstairs it looks like I have a 4 in this case. So it looks like I end up with 0 upstairs, and this negative, who cares? And downstairs I end up with a 1, and 0 over 1 is 0. But don't forget, you had exponentiated things, so what we just found is that the side we focused on goes to 0, but I still have to go figure out what happens to y, which is what I called this guy to be. So ln of y is what goes to 0 after this analysis, and you have to remember to exponentiate both sides. So y looks like it goes to e to the 0, which is 1, which means ultimately limit as x goes to 0 from the right of tangent 4x to the x was the problem. Yep, is equal to 1. So it took a few tries. Type 3 turned into a type 2, and then ultimately turned into a type 1 with a few steps of L'Hopital.